I'm tackling a problem using Sklearn's KFold for cross-validation. I have 12 samples of data, splitting them into 3 folds. Importantly, I'm shuffling the data randomly before splitting, which is crucial for unbiased results. I'm working with a dataset that contains 12 individual data points. I'm using the KFold technique to split the data into 3 distinct groups, folds, for cross-validation. The shuffle equals true argument ensures that the data points are mixed up before division for a more robust evaluation. KFold is an abbreviation of KFold cross-validation. I'll be asking you to identify which statements about the created folds are definitively true. This statement claims each of my 3 folds will hold precisely 4 samples. However, this isn't guaranteed, because 12 samples divided by 3 folds does not produce a whole number, resulting in unequal fold sizes. This proposes that each sample will feature in exactly 2 folds. I find this statement to be true. Since each sample is in the test set only once, out of 3 folds, it must be part of the training set for the other 2 folds. This suggests that the training sets used in the 3 folds don't share any common samples. I find this statement false, because KFold's training sets always have some overlap. Samples are reused across folds. This claims that every one of my 12 samples will be present in the training sets at some point. This statement is true, because each sample appears in the test set exactly once, meaning it's in the training set for the remaining 2 folds. This question asks you to think about how KFold cross-validation works. We're using Sklearn's KFold function to split 12 data samples into 3 groups, folds, randomly. The goal is to figure out which statements about those folds are always true. I see this because I have 3 folds, and each sample appears only once in a test fold, the one it's left out of. It must show up in the remaining 2 training folds. Absolutely. Think about it this way. Each sample is only held out for testing in 1 fold. That means it is definitely part of the training data in the other 2 folds. Therefore, all 12 samples are present in the training sets across the 3 folds. This is tricky. The test sets are mutually exclusive, no overlap. But because the samples are reused across different training folds, there will be overlap in the training sets. For example, one sample might be in the training set for fold 1 and fold 2. Nope, while KFold tries to make folds roughly equal in size, 12 samples, 3 folds approximately equals 4 samples per fold. It's not guaranteed to be exactly 4 due to how integer division works. Some folds might have 3, while others have 4, but it would never be less than 3 or more than 4 samples in any fold. I'm using KFold cross-validation, a technique to evaluate machine learning models. I have 12 data samples and I'll split them into 3 different groups, folds, for training and testing. The K in KFold refers to the number of folds, which is 3 in this case. I'm using Sklearn's KFold function. _n_splits equals 3 tells it to create 3 folds. _shuffle equals true means I'll randomly mix up my data before splitting. This ensures that my folds are unbiased and representative of the data. The result of this process will be 3 distinct folds of my data. Each fold will be used once as the testing set, while the other 2 folds will serve as the training set. This statement is likely false. While KFold aims for equal-sized folds, with 12 samples and 3 folds, it's unlikely to create perfectly equal groups of 4 samples each, due to the nature of integer division. There might be slight variations in the number of samples per fold. Think of trying to divide 12 cookies equally among 3 friends. Some friends might get slightly more or less. This is correct. Since I have 3 folds, each sample will be in exactly 2 training folds, because it will be held out for testing in exactly 1 fold. This is a core concept of KFold cross-validation. This is also correct. Every sample is used for training in at least 2 folds because each sample is only held out in 1 fold for testing. Therefore, across all folds, every sample appears in the training set. This is crucial for a thorough evaluation. This is incorrect. Because of the principle of repeated use of samples in different training sets, the training sets will overlap, meaning some samples will be present in multiple training sets. We have 12 data points to work with. Think of these as 12 different examples we'll use to train and test our model. I'm dividing the data into 3 separate groups or folds. Each fold will be used once as a testing set, and the others will be used to train the model. This is how we'll evaluate how well the model generalizes to new data. Before I split the data, I randomly shuffle it. This ensures that each fold is a fair representation of the overall dataset, preventing bias caused by data order. I'm doing cross-validation using 3 folds, KFold cross-validation where K is 3, with a dataset containing 12 samples. This involves splitting the data multiple times, training and testing the model on different subsets of the data to get a more robust performance estimate. Okay, now let's look at the statements and see which ones we can guarantee as true. This isn't guaranteed. While I aim for roughly equal-sized folds, 12 samples, 3 folds approximately equals 4 samples per fold, it's not always possible to split 12 samples perfectly evenly into 3 groups. This is absolutely true. Since I use each fold once for testing, each sample appears in the training set for the remaining 2 folds. This one's false. My training sets will have overlapping samples because a sample used for testing in one fold will be part of the training set in the other 2 folds. This is also true. Each sample is held out only once for testing, it's included in the training set for all the other folds. I'm presenting a question about KFold, a cross-validation technique in Sklearn. We'll analyze the results of splitting 12 samples into 3 folds, randomly shuffling the data before splitting. The key is to determine which statements about the resulting folds are definitively true. With 3 folds, and each sample appearing once in a test fold, I can confirm that each sample will appear in exactly 2 training folds. It's like having 3 groups, and each person must be in 2 of the groups. Simple, right? Because each sample is only used once for testing and each sample should be part of the training set in all but one iteration. I'm sure that all 12 samples will be present in the training sets across the 3 folds. It's guaranteed. I see your point, but no, this isn't guaranteed. While KFold aims for equal-sized folds, with 12 samples and 3 folds, we'll have some folds with 4 samples and others with either 3 or 4 due to integer division. That's the reality of it. Nope, this one's false. KFold makes sure test sets don't overlap, but training sets will overlap. Think of it, if I remove one sample for testing, the remaining samples form a training set. But I do this for each sample, resulting in overlapping training sets. I'm using Sklearn's KFold for cross-validation. I have 12 data samples and I want to split them into 3 folds. KFold is a technique to divide your data into multiple parts for training and testing a machine learning model. This helps evaluate the model's performance more reliably. I'm working with a dataset containing exactly 12 samples or data points. Think of each sample as a single observation in your data. I've set the number of folds, or splits to 3 using *n_splits equals 3 *. I also set *shuffle equals true * to randomly shuffle the data before splitting to make sure I don't introduce bias. I'm using the KFold algorithm provided by Sklearn. It's a popular method for doing KFold cross-validation, a way to systematically evaluate my model. This is the core question. Which of the 4 statements will always be true given my data and settings? Let's analyze each statement carefully and see what guarantees we can make. The result of applying the KFold algorithm is a set of folds, which are the different ways my data is split into training and testing sets during cross-validation.